want, we're going to be able to show things based on the average, but what we want is the maximum to go to 0. If the worst possible message still has a probability of error that goes to 0, then we're okay. Then we can promise reliable communication. There are 9 definitions, we're almost there. The rate R of a capital M, little n code in bits per channel use, excuse me, in message bits per channel use. Let's see if we can figure this out. How many, so there are M messages, so how many bits do I need to express M messages? Log 2M, so that's the number of message bits. I'm going to ignore, I could use ceiling, but I'll ignore that. And how many channel uses are there in this code? N. So R is log 2M for N. Okay. Now the rate, we can calculate. The rates of codes. Let's go back to the example I had a second ago. In my example, M was 1, 2, and N was 4. So what is the rate of that code? So, excuse me, this is the set of possible messages. So M was actually equal to 2. So log 2 of 2 is 1, and the denominator is 4. So the rate of that code is 1/4. So that makes sense. So I start with 1 bit. I can distinguish between these two messages with 1 bit. And I expanded them to 4 bits. So it makes sense that the rate of that is 1/4. So for each channel use, I'm basically sending 1/4 of a bit. Okay. The next definition rate R. So this is really what we mean by reliable codes. So a rate R is said to be achievable. Said to be achievable in a reliable transmission sense. If there exists a sequence of code, a sequence of ceiling 2 to the NR, N codes such that the maximal error probability first off, what does this mean, 2 to the NR? Well, if, let's go back to our example of 1/4. 2 to the NR, if R is 1/4, that's 2 to the N over 4. So this is basically the number of messages corresponding to the number of output bits for rate 1/4. So in other words, if N is equal to 4, then the number of messages is equal to 2 to the N over 4, which is 2. That's the example we had a second ago. So we put in 1 bit, log 2 of M, and we get 4 output bits. N equals 8, we have M is equal to 2 to the 8 over 4, 2 squared, which is 4. So you'll see in each case here, N equals 12, M equals 2 to the 3, which is 8 possible input messages, and so on. You'll see that the rate, remember my rate, assuming this is an integer, just get rid of the ceiling, rate is equal to log 2, 2 to the NR, divided by N. So in fact, putting 2 to the NR here, that's basically how many messages you need corresponding to each rate, because what I get on the right here, log 2 to the NR is equal to NR over N, which is equal to R. So if I have a rate of R and N as my number of channel uses, then my number of messages must be 2 to the NR. So basically by a sequence of codes, we're going to sort of see more what that means later. What we're going to be doing is we're going to be assembling, we're going to be introducing what are called random codes. So in other words, for each possible message, we're going to assign it a random string, a random encoding string. And then we're going to observe what happens at the channel output for that random encoding string. So sequence of code sort of makes sense in that context, because I can clearly take a code of length n that's random and extend it to a code of length n plus 1, and n plus 2, and n plus 3. And then what I can see is I can watch the effect of that on the probability of error, and hopefully the probability of error will go to 0. So in that sense, the statement "there exists" is not very helpful. I'm not saying a radar is said to be achievable in a reliable transmission sense if here's how to design a sequence of codes. I'm saying there exists. So in fact, as long as you can write down a sequence of codes starting with n equals 1, n equals 2, n equals 3, and so on and so on and so on to infinity, as long as you can write down such a sequence of codes, then the radar is achievable. It's important to note, again, I'm not telling you how to write down that sequence, only that it exists. The proof of most of the theorems here, or the proofs of most of the theorems here are existence proofs. They're not constructive proofs. So we're just going to say there exists such a sequence. There's absolutely no sense of how to design, how to build them practically. Finally,